Last video in lecture 9, almost done. We are given a proof. Thank God, we don't have to come up with anything, we just gotta look at this. And we are given that someone named Bandar, who was in IA last semester, wants to use induction to prove this statement that n factorial is greater than n squared for all n greater than or equal to 4. And he gives us the following proof, but it's not right. And we're gonna figure out why. So we just gotta read this. Let's see, inductive step assumes P of k is true for an arbitrary k. That's good. And wants to show P of k plus 1. Sounds great. Let's see, to prove this, starts with one side of what we want to prove, works down to the other. And let's look at some of these steps. Just on this first line, uses factorials to split this up, probably because then we can use our assumption. And then look, uses the inductive hypothesis assumption to get this inequality here. Then just splits up the k squared. And then uses the fact that k is greater than or equal to 4, which I feel like we should have said up here when we said let k be arbitrary. But anyway, k is greater than or equal to 4, told up here. So it's definitely greater than or equal to 2. So do this substitution, because then we can do k plus k, and then we can come down here, and k is definitely greater than or equal to 1 also. And now we're lined up. All looks good. And what's left over is our base case. N equals 0 proves it for p of 0. Fantastic. Except what happens for p of 1? We get 1 factorial, which equals 1 greater than 1 squared. That's not true. Uh-oh. It's because we're only proving this for n greater than or equal to 4. This is not a good base case. That's it. That's actually the issue here. The base case is wrong. I made you listen to me talk through this whole rest of the proof just to get to the base case, but the rest of the proof does really nifty tricks that are hard to see when we're coming up with them on our own, so I thought it might be useful to talk through some of them, because you'll have to come up with tricks like this for the homework and the exam. And now we're done.